Notches and weir are small symmetrical opening at the side of reservoir where water flows over its crest level. We have to understand here this crest level. Notches and weirs are both the geometrical opening. But what is the difference? Notches are used to measure the discharge through small channel, and notches and weirs are used to measure the discharge through channel or reservoir, but large flow. So notches are used for small and weirs are used for large discharge measurement. And we have notches are made up of metal and weirs are made up of masonry structure. Let's explain about notches and weir with the figure. This is top of the crest. Here is the reservoir with liquid. By the definition, water flows or liquid flows over its crest level. This is the crest, so this level is the crest level, and liquid flows over it. Means liquid free surface is here, and this flows over here and goes downward. Here this is the free surface, and this height h. This height h is the head over the crest, and this is crest line, crest level, and this free surface bending downward from here. We can draw a straight line. This portion is called drawdown. This is a stream of Z. In case of notches and weir, we call it as a nappe or vein. This top is called crest or sill. Liquid flows down the weir and it makes here circular rings, and water rises up to some free surface here and it flows forward the this level. Now we define all the terms related here. Here some velocity is considered, sometimes not considered. Let Va is the approach velocity here. Due to this velocity, the liquid have some head. Let this head is Ha. Head due to velocity of approach is Ha. Actually, velocity of approach is the velocity through which it approaches to the notches or weir. Is the velocity of approach. First, crest and sill. Crest or sill is the top edge of the notches or weir, above which the water flows. And now we have this head H. This head H is the depth of liquid or height of the liquid above the crest level. We have this Napier vein. Now we have velocity of approach B. It is the velocity through which it approaches, the liquid approaches to the nose or weir. We have this HA, velocity head, velocity of approach head. This is the head due to the velocity of approach. You can write. Now we go through the classification of noses and weir. Classification of noses and weir. What are the types of noses and weir? There are different bases on which noses and weir are classified. First, according to the shape and opening of the weir. According to the shape and opening, we have rectangular, triangular, trapezoidal, compound, circularity. We write here. By the name, we know this is of triangular shape and this is rectangular shape. Name denotes the figure. These are the geometrical names. Figure are also geometrical. I'm gonna made here the figure of this noses and weir. I start with the rectangular weir. Here I made only the cross section. Here I have drawn the figure of 6 types of weir or notches. First one is rectangular weir. Its cross section is of rectangular side, and this is of triangular shape, and this is of trapezoidal shape, and this is of semicircular. Here is semicircle, and this is like a hexagon. Here is like a hexagon, so it is called compound. This is also like this trapezoidal. What is it? It is called superlative weir. Superlative weir is this special type of weir where horizontal to the vertical ratio is 1:4. These are on the basis of shape and opening, and another is according to the effect to the sides of the nappe, and another is according to the effect to the sides on the nappe. We know nappe is the jet, like a jet, it flows over the crest level, down the crest level. How nappe is affected? The flowing liquid, how affect this nappe? On this basis, we have 2 types of weir. First one is suppressed weir. Second is contracted weir. Suppressed weir. It is such type of weir in which crest length is equal to width of the channel. And contracted weir. Contracted weir is such type of weir in which crest length is less than width of the channel. If you do not understand this, I will try to make you understand by drawing a simple figure here. Here I will make the rectangular weir. This is rectangular weir, and I will make another also. Here are 2 figures. Water flows here, and water from above in second figure approaches like this. Here water is approaching to the notch and flows down, and in this case water is approaching from here, and later it flows down the weir. This is actually the total width of the channel, but crest length is of length L. But in this case, water level and crest level are equal. Width of the channel and crest level are equal. So this is suppressed weir, and crest length is small in this case. So this is contracted weir. This is all about the suppressed and contracted weir. Now we move to another according to the shape of the crest. According to the shape of the crest, we have different types of weir. First one is sharp crested weir. And on the we have narrow crested weir. CW, crested weir, and third, broad crested weir, and fourth we have OG shaped weir. By the name, we know the crest is sharp. Narrow crested weir, crest not sharp. Broad crested weir means width of the weir is large and crest is wide. OG shaped weir is the where position of the water spills away. I will make the figure here. OG shaped weir. This is OG shaped weir. Water spills away over the weir. Here. This is OG shaped. So it is called OG shaped weir. We write here. Position of dam over which liquid flows. And sharp crested weir is such type of weir in which width of the weir is less than head by 2. And this narrow crested weir, width of the weir head h upon 2, and broad crested weir, width of weir is greater than head upon 2. This greater h by 2. Head is h. We know width of the weir and we know head. Suppose I will make here figure here. Suppose this is weir, sharp crested. Here water head is here. This head h is h by 2 is greater than this width of the weir. We can see here width in this side. H by 2 is greater than this width, so it is called sharp crested weir. Now narrow crested weir. Crest is not sharp, so we can make here is this type of figure. Let this is width. This width is less than this h by 2. Let this is h and h by 2 this is, and this is narrow crested weir. Width of weir is less than h by 2. And broad crested weir. For broad crested weir, I will make here figure, modify here. This is broad crested weir. This crest is broad. Width of the weir is greater than h by 2. So it is broad crested weir. OG shaped weir is this type of weir. Now we have another basis according to the discharge. By rubbing this, according to the discharge condition, we have two types of weir. First one is ordinary or free discharging weir. And second is drowned or submerged weir. Ordinary or free discharging weir, we can study this discharge condition, where we can compare with the orifice, free discharging orifice and drone or submerged orifice.